Good morning, students. Today, let us learn grade 9 state board, grade 9 chemistry. The chapter name is matter in our surroundings. Matter in our surroundings. Is it clear? Now, that means what? What is concerned? That means around us, whatever it's made of matter. What is definition for matter? What is definition for matter? Anything that has mass, and that has mass, occupies space, is called matter. Is it clear? Anything that has mass and occupies space is called matter. Clear? The definition for matter. Now, as per ancient scientists, they defined matter or classified into 5 types. They call this as Pancha Tattva. Panch Tattva. Panch Tattva. Panch Tattva means 5. What is that 5? First one is air. Second one is earth. Third one is fire. Fourth one is sky. And fifth one is water. So all these are made up of matter. Correct? Panch Tattva. Panch means 5. Okay. This was described by ancient scientists. Now, as we know, matter are divided into 3 main divisions. Actually 4 it is. I will show you the 4th one also, but only 3 is required for you. Now what is that? Solid, liquid, gases and plasma. This is not there, but I'll tell you where it is. Okay, solids, liquid, gases and plasma. This is, as I said, this is not there for us. Now let us know little at least of that. Okay. Now, what are solids? What are liquids? What are gases? Now, if you see in solids, I will give you points one by one for all these 3 together. Okay. In solids, the atoms are closely packed. The atoms are, first point, the atoms are closely packed. Whereas, in liquids, the atoms are loosely packed. Okay. In gases, they are freely moving. The atoms are freely moving. Clear? So, first difference I give. You will have a question. Differentiate between solid, liquid, gases, or differentiate between solids and liquid, or differentiate between liquids and gases. You should know. Okay. Here, the atoms are closely packed. That means there is no gap between the between the atoms. So they are closely packed. If I take and show you like this. Whereas in the liquid state, they are loosely packed. Whereas in gaseous state, they are freely moving. Okay? Okay. So, if you want to know the structure, I can show you this way. You can see that solids, liquids and gases. Is it clear? Can you make it up? Solids, liquids and gases. Okay. Now, this first point I give you. The second point, what we say here is kinetic energy. What do you mean by kinetic energy? The energy excited between the 2 atoms. Okay, the kinetic energy is less, least or less. Here the kinetic energy is more, between the atom is more. Here the kinetic energy is most. That's why if you take a balloon, blow air in the balloon and prick hole anywhere, you will get the same pressure out. Is it clear? Kinetic energy is more on. Okay. Now, what is the shape? The solids has a fixed shape and volume, whereas liquids they have fixed shape, but they don't. They take the shape of the shape is based on the container. Okay, they take the shape of the container. Whereas gases, they also take the shape. They have mass, but they take the shape of the container. Okay. Here liquids also they have a shape. Okay, and they have mass, but they take the shape of the container. Whereas gases, they take the shape of the. They have a mass, but they take the shape of the container. Is it clear? Only the solids have both here. Fine. Now, in gases, if you see, they exert more pressure. You see, in gases, if you know LPG, what is LPG? Liquefied petroleum gas. What is LPG? Liquefied petroleum gas. Liquefied petroleum gas. Next, CNG, compressed natural gas. Clear? Compressed natural gas. Is it clear? The next one is, here if you see LPG, CNG, and one more, what is that? The other one is you can see the oxygen cylinders, no? Oxygen cylinders. So all these oxygen cylinders are used in the hospitals. Now if you see for this COVID, oxygen cylinders are very much required, because our oxygen level is coming down when you get COVID. Okay. Now, so these are the gaseous states now. Correct. Now, next one is plasma. Where you see plasma? Plasma, you see plasma in sun and stars. Okay. You can see them burning. Okay. Now, say, sir, can you show plasma somewhere near to us? Yes, you can see our neon bulbs, sodium vapor bulbs. Okay, all this plasma state is there in that, inside the bulb. When you switch on the light, you can see that brightness. Okay, that means what? The gas will take that color. Correct? So here the gas is ionized. That's called as plasma state. Is it clear now? The gas is ionized. The gas is ionized. Yes? Is it clear? Now, in your books, it says that, in the book it says that if you see how much small is the matter, how much small is the matter, that means it keeps on dividing. For example, if I take a beaker containing water in this and add one crystal of potassium permanganate, if I add one crystal of potassium permanganate, whole thing color will change to pink. Now this again I will take 10 ml of that, add into one more beaker containing 100 ml water, and then again you can see the color. Again I will take this 10 ml and add into 100 ml water. Okay, again you can see still it's dividing. You can see the still color, but here the color is very dark, here the color is fading little slow. That means the atoms are further, that means what? The particles are being further expressed in this way. Is it clear? Okay. Now, here I will show you one more experiment. In the liquid, I said the liquid will take the shape of the container. You can see that I have taken. Okay. Now I add salt to this. Is it clear? I have added salt to this and I'll stir it. Now what happens here, you see what you observe here, that means where is the salt gone? Did the volume increase? No. Then where the salt gone? The salt have went and occupied the space between the atoms. I said no, they are loosely packed. Okay, so the salt went and occupied the space between the atoms. Is it clear? You understood now? This is a small activity for you. Okay, now if you see the gas now, see the gas, you see that molecules reaches the end of the room. Now for example, if I spray here, I will get the smell first. That means I can smell it. See, the molecules are very close to me. Okay, so the molecules will take time to reach the corner. Okay, the students sitting in the last desk will smell little later. Okay, is it clear? Now, same way, like that, in this also, you see, here potassium permanganate we have taken. Sir, you can take one more example also. You can take Dettol, liquid Dettol. Liquid Dettol you take, put it in a container, a beaker containing water, so that you mix it. Again, you pass it on to the next beakers. You can see still the smell is there. That means what? The particles are very smaller and smaller. Is it clear? Now, if you come to this one, here in solids, the gases compressed. They are highly compressible. The gases are highly compressible. Is it clear now? Now, based on the physical change, I'll give an example here. Based on the physical change, can the matter be changed from one form to other form? Yes. What is that? We'll see. Physical change. Okay. Now, I will take water. Okay. Now, okay. I will take solid. Okay. One solid, liquid, gas. I am giving an example here. Solid is your ice. Ice is a solid. So when I heat it, what will happen? When I heat this ice, what will happen? Heat the ice, what will happen? It becomes liquid. So solid, liquid. When I heat this liquid, it becomes steam, gas. Okay, it's nothing but steam. Clear? Solid to liquid, liquid to gas. See the changes now. What has happened now? Now it was in solid form. When I heat it, the molecules have separated and become liquid. When I heat it again the molecules are separated, become steam. Is it clear? So I have taken one example as ice and shown all three states of matter. Is it clear now? Solids, liquid and gases. Okay, now I will, in the exams, what I do, what is this called as heating, correct? I'll make this as A and I'll make this as B, correct? And I'll make this as C. Now solid to gas to solid. C, what is this? Now that means what? If I heat this, if I heat the liquid, it's called evaporation. Clear? Correct? This is heating. Correct? Now this gas directly can be condensed to solid, or solid can be changed directly to gaseous state. For example, that is called as sublimation. What do you call this as? sublimation. What do you call this as? Sublimation. That means without going to liquid state, the solid can reach the gaseous state. For example, you know this odonil we keep in the washrooms, okay, and you can see that naphthalene balls we keep it in the almirahs, or you see some bigger naphthalene balls will be kept in the washrooms also, toilets, where that means that is a solid. That solid is getting evaporated directly to gaseous state. That's why you get very good smell, no? So it will remove the bad smell. Correct. So that process is called sublimation. So heating, evaporation, and sublimation. So this we have to remember very much in this particular topic. Is it clear? So next class let us learn the changes happening. Okay. Now it's clear now. Here in this chapter, what they have expressed more is the evaporation. How the evaporation takes place. Now, if you take I'll show you now. Condensation. You can see one experiment. I'll show you an experiment. In this, if you see the water, I'm heating a water in a round bottom flask. Okay, I heat a water in this round bottom flask. Okay, this is your fire. Okay, now this is connected to the delivery tube. This is called as delivery tube. Okay, now this delivery tube is connected to a condenser. So the condenser has inlet, cold water will go inside and comes out from this. So what happens here, now this all is covered, and you can keep a thermometer also here and measure the temperature. Okay, now as the water is heated, the water is getting coming vapors. These vapors are moving, and as it's coming to the condenser, here the water is flowing in this condenser. So water is going into this condenser. So it is cooling there. So once the steam is cooled, it forms again liquid. Okay, it forms again liquid. So this process we call it as evaporation and condensation. Okay, you'll get that water, purified water, the distillation. We call this as distillation process. Okay, that means the water I purified it. Purified means what? I first converted that to steam. From steam again I converted to a liquid form. Correct. So now if you see this in your book, they are given as a sublimation. So they are taking a china dish here. Okay, china dish. In that china dish, what this aluminum chloride is used here. Aluminum chloride is used. So in aluminum chloride is used, we put on funnel here. To that funnel, we will cover with on cotton there and heat this. So what is this called as? Ammonium chloride vapors. Here we have taken ammonium chloride. Ammonium chloride. Take this ammonium chloride, heat it. You can see that vapors here. Ammonium getting condensed here. Okay. So this is also one type of sublimation of ammonium chloride. Okay. From solid to gas, again it forms solid. Okay. Now that this covers your a small topic, matter in our surrounding. Okay. Now let us see in the next class. We'll go in detail. Fine. Thank you. Stay home safely.